My name is Thorsten Butz, and I'm talking about epochs. What's an epoch? An epoch is a special moment in world history. For example, when man first left the Earth and traveled into space. Remember about that. After that, you might call it an era where people started to conquer space. And if you think about time, do a thought experiment. Imagine we start a metronome at this moment and count the beats of the metronome. We could call this interval a second, and we would already have a measure to describe periods of time. Unfortunately, that would lead into big integers, right? So we created something that's 60 seconds is a minute, 60 minutes is an hour, 24 hours is a day, and then it gets really confusing, isn't it? Why is that so hard? I've always asked myself, can it be simpler? What if a computer scientist like Gottfried Wilhelm Leibniz had designed time? Leibniz, who popularized the binary number system, then perhaps 2 seconds would make a minute, 2 minutes an hour, 2 hours a day. That seems familiar, right? Yeah, but it's a little bit different. In reality, people have always observed the stars and observed that the Earth revolves around the sun as it rotates on its own axis, and it does so a little less frequently than 365 times. We call this revolution around the sun a year. And this is the basic thing of our calendar, which is essentially goes back to Julius Caesar. The so-called leap years were introduced in order to compensate for the small deviation the descendant places. Unfortunately, the Julian calendar is not like correct. So at the behest of Pope Gregory, this calendar was reformed in 1582, cancelling a number of superfluous days from the old calendar and significantly improved the leap year rules. In principle, this is still our calendar today. In IT, we do find all this in an ISO standard. Here, the epoch begins on January 1st of the year 1, and we count up to the year 9999. That is basically our understanding of a calendar, how we use it every day. But it's a bit strange if you now look into PowerShell. Interestingly, it's not possible to calculate backwards in this implementation, right? You can't go do a subtraction. We can see this here in PowerShell. However, you can also see that on our computer, we have the option of resolving time much more finely than just in seconds. In computer science, the so-called Unix era is particularly important. Many applications are based on counting the seconds since January 1st, 1970, the birth of Unix, so to speak, and keep that in mind, that's always UTC that will be important. In the PowerShell, we find numerous implementation options. Here you can see some of them. All timestamps are identical. That's interesting, as you can see in the last line. I have to warn you a bit about the commandlet getDate, because it almost always outputs time in your local time on the machine. And here, in the Unix time, it's now also possible to go back in time to before the 0 hour, so to say. So the moon landing has a negative time value, but it gets a little bit more complicated, as you see now. If you now want to calculate the so-called Unix time, so the seconds since January 1st, 1970 in UTC, there are lots of possibilities. You see 2 of them here. But you could also use the getDate commandlet and the uformat parameter to output the seconds that had elapsed ever since. But in PowerShell 5, this is also stupidly done using the local time. And this is simply wrong in UTC-based Unix time. And so this has also been corrected in PowerShell 7, as you can see here. And in addition, integers are now always the output. Take care of that. You will know that we have another important player here. In the Windows world, we often encounter the epoch that begins January 1st, 1601. This is very important in the development of Windows NT, and I've tried to illustrate why this is the case in a graphic. Since the Gregorian reform, we can generally consider intervals of 400 years. So if we want to consider a first complete so-called Gregorian cycle, this is the time from 1601 to the year 2000. And Windows NT was developed in this cycle, and it therefore seems logical that they take this date as the beginning. A very, very well-known use case can be found in Active Directory. You all might know that. If you look under the hood there, you will find the last logon timestamps, obviously ticks that are intervals of 100 nanoseconds. And if you look behind the scenes, and then it's a little bit dangerous to try to convert these timestamps just like that, because you see, it's not very likely that Bill Gates had logged on in the year 424, as you see here. And you can guess why this is a problem here. Unfortunately, datetime objects are based on the year 1. If I want to correct this, all I have to do is add this Win32 epoch on top. In other words, simply add 1,600 years, and you have the correct time data in UTC, of course. Summarize, time can be very tricky. Be careful with the time zones, be careful with daylight saving time. And one last very simple piece of advice, never blindly trust get date. In the notes of the presentation, you'll find a couple of scripts, a couple of code lines that can verify how dangerous this is. And yeah, it's well worth a look. And that's what I wanted to show you. Thank you for your attention.